Welcome to Mrs. Rensberger's Mathemagical Podcasts. Today we're going to talk about one-step equations. We're going to start with the equation x plus 7 equals 4. When you're solving an equation in algebra, the whole purpose is to get the x by itself. In this equation, the variable is on the left side of the equation, and it has with it a plus 7 or a positive 7. So we need to get rid of that plus 7. In doing so, we're going to subtract 7 from both sides because an equation is a balance, and therefore whatever we do to one side, you have to do the same thing to the other side. Positive 7 and negative 7 are called additive inverses, and we know that when we add them, you get 0. So therefore on the left side of the equation, you're left with x. On the right side, we have two integers that have different signs. And we know that if two integers have different signs, we subtract their absolute values. So 7 take away 4 gives us 3, and since we have more negatives, our answer is negative 3. If we were to plug this back into the equation, we would find that negative 3 plus 7 does indeed equal 4. Let's suppose we had x minus 12 equals 3. So now we have a subtraction problem. Remember, you always do the opposite, and you always get rid of the number that is on the same side of the equation as your variable, because we want the variable to be by itself. So therefore, I need to get rid of this minus 12. And in doing so, I'm going to add 12 to both sides. And so when I add 12 to both sides, these 12s cancel because they're additive inverses. And over here, my signs are the same. And we know that when integers have the same sign, we add their absolute values. So therefore, 12 plus 3 gives us 15. To check this, we would plug 15 back into our equation, and we would find that 15 minus 12 does indeed balance our equation. Let's suppose instead of add and subtract, let's suppose I had multiplication. We can see these two numbers are snuggling, therefore they're multiplying. Remember, we always do the opposites. So the opposite of multiplying by 6 would be to divide both sides by negative 6. In algebra, do not use the old division sign. We want to remember to use the fraction bar. So when I divide both sides by negative 6, these negative 6's, negative 6 divided by negative 6, cancel to a positive 1. And 1x, we know, is the same thing as x. So therefore I don't have to write the 1. And then 48 divided by negative 6, my signs are different. And we know that if signs are different, our answer is going to be negative. And that's the multiplication division rules for integers. So therefore I get a negative 8. Negative 6 times negative 8 gives us a positive 48. Now in this problem, we start with a fraction. So what we know is that fractions are division problems. See that old division symbol I was just talking about? It's really like a fraction, numerator over denominator. Isn't that cool? So therefore, this fraction is a division problem. So to solve it, remember we do opposites. We want to get rid of the number with the variable. The opposite of x divided by 6 is to multiply both sides by 6. Those 6's cancel out because really, this is 6 over 1. And I'm reducing a numerator with a denominator. Therefore, I'm left with 1x, which remember is the same as x. And 5 times 6 gives us 30. These signs are the same. And remember, if the signs are the same when we multiply and divide, we get a positive answer. So positive 30 divided by 6 does give us 5. I'm going to do that same problem one more time, but we're going to write it just a little bit differently. Remember this x up here? It has a coefficient, but we don't write it. So I could write it like this. Okay? So that's the same as 1/6 times x equals 5. Instead of dividing by a fraction, we're going to use the multiplicative inverse, which is multiplying by 6 over 1. Oops, I'm sorry, 6 over 1. Okay? And so these 6's cancel out. We get x. And then 5 times 6 gives us 30. It's the same thing that we just did over here. The opposite of dividing by 6 was to multiply by 6. But this had a 1 in front of it, which is 1 over 6. And check it out. The inverse of 1 over 6 is 6 over 1. So I showed you that because our next problem is going to have a fraction as the coefficient. So we're going to do -2 over 7 times your variable x equals 4. So now you know you don't want to say the opposite of multiplying by -2 over 7 is dividing by -2 over 7. I mean, who wants to divide by a fraction? That's crazy. So instead, let's get rid of that mess. We don't divide by fractions. Instead, we multiply by the reciprocal. So I'm going to multiply both sides by -7 over 2. The reciprocal is the same thing as the multiplicative inverse. Okay? So what I'm going to do is I'm going to reduce my numerators and my denominators. 7 goes into both of those. 2 goes into both of those. You know, this has a 1 under it. We just didn't write it. But if you put a 1 under it, you can say this is a numerator and this is a denominator. So 2 goes into 2 once. 2 goes into 4 twice. All of these are 1s. Negative times a negative is a positive 1 times x. Remember, we don't really need that 1. Magic. So 2 times -7 gives us -14. What you just did up here, we reduced, remember? We reduced our 4 and our 2. Some of you might prefer to do 4 times 7 is 28 and do -28 divided by 2. That's still going to give you -14. Thank you. I hope you enjoyed this, and I hope that from now on your one-step equations will be super easy.